Today we're talking about inverse functions. Functions are inverses of each other if you have f of g of x, and if you were to solve this, you would end up with x, or vice versa. Okay, the function, whatever it is denoted by f to the negative 1. So really, if this was written f, this should be f, the inverse function is f to the negative 1, and is read as f inverse, or inverse of f. Okay, so if your original function is f of x, your inverse function will be f to the negative 1x. If your original function is y, your inverse function will be y to the negative 1. So it's just showing you that 1 is your original, and this is telling you this one is the inverse. Okay, the way to find an equation for the inverse relation or the inverse function, the first thing you want to do is in your equation, you exchange x and y in the equation. Then you are going to resolve the equation for y. And remember that instead of writing that y equals, you are going to write that y to the negative 1 equals, denoting that it is an inverse. Okay, so we're going to go ahead and start example 1. So notice here we have y equals negative 3x plus 2. So on this problem, we are going to exchange x and y. So that means my inverse function I'm going to write as x equals negative 3y plus 2. So I just exchanged the x and the y. And then now we have to resolve this so that y is by itself. So I would do that first by subtracting 2 to both sides. So now I have x minus 2 equals negative 3y. And the last step I would do is divide each side by negative 3. And then y is all by itself. So now when I write this answer, though, instead of saying y equals, I write y to the negative 1 equals x minus 2 over 3. Oh, sorry, over negative 3. And this is your answer for the inverse. Okay, let's try example 2. So on example 2, again, we're going to exchange x and y. So I will rewrite this as x equals 2/3 y plus 7. So now we need to solve this for y. And the first thing I think I would do is get rid of the fractions. And I would do that by multiplying the entire equation by 3. So I'm just going to go through and write a 3 next to everything. So I end up with 3x equals, here my 3's cancel out and I get 2y plus 3 times 7 is 21. And again, we're trying to get y by itself. So my next step here would be to subtract 21 to both sides. So I have 3x minus 21 equals 2y. And then the last step is to divide by 2 so that y is all by itself. And then when I write my answer, I write this as y to the negative 1 equals 3x minus 21 all over 2. Okay, so in this now we have find the inverse of the power function. So here we just had plain x's and y's in example 1 and 2. Here now I have x to the second. Now the first thing is we exchange x and y. So anytime you have f of x, you could always change the f of x to y. And so I'm just going to rewrite this as y equals x squared. And then again, we are exchanging the x and y to find our inverse. So when I exchange x and y, I get x equals y squared. And we need y by itself. So how do I get y by itself? What will I need to do in order to get y by itself? Hopefully you said take the square root, because if I take the square root of y squared, I just get y. And whatever I do to one side, I have to do to the other side. So this will be the square root of x over here. Now, my original equation was f of x. So when I write my answer, I'm going to write this as f to the negative 1 of x equals the square root of x. And that's your answer. If you wrote y to the negative 1 equals this, I would not mark it wrong. But it's always best to go back to how it was written originally. Okay, so let's move on. Okay. So again, we have example 4 and we have f of x. So I'm going to go ahead and write, instead of having f of x, I'm going to change that to be y. Okay, so now we're going to find the inverse function. So that means I'm going to exchange x for y. So we're going to write this as x equals negative 10 x to the 6th power. Oops, not x. Sorry. Negative 10 y to the 6th power. Okay, so we want to get y by itself. So the first thing I would do is get rid of that negative 10. So we're going to divide by negative 10 to both sides. So now we have x over negative 10 equals y to the 6th power. So now how am I going to get rid of the y to the 6th? Okay, so we have to take the 6th root, okay? And whatever we do to one side, we also have to do to the other side. Now, we're taking the 6th root of this whole thing, but I'm going to end up writing it as, well, we could do it like that, the 6th root of the whole thing. And then we might end up separating that. But actually, I'm looking at your homework and stuff. So we have y to the negative 1 or f to the negative 1 of x equals the 6th root of x over negative 10. If you notice back at the original problem, it tells you that x is less than or equal to 0. Which numbers are less than or equal to 0? Negative numbers. So what that means is if you put a negative number in here, two negatives will end up making a positive number. Okay, and so this is my answer. Some of you might be saying, wait, this really means the 6th root of x over the 6th root of negative 10. The reason that we are not going to worry about this right now and not worry about the root in the denominator is that we need the value, the negative value here, to make these two negatives positive. And so for this homework assignment and for these problems, you can just leave the 6th root over the entire thing and not worry about the roots in the bottom. And the reason, again, is why we need to have that x in order to make this statement true. We need to know that value. So it's hard to do the work without having this as a negative x, because we'd end up with an I, which we really wouldn't if we knew what x was. So don't worry about roots in the bottom for right now for these problems, because we need to know what x is in order to solve it correctly. Okay, so example 5 is similar. So again, I'm going to write this as y, and we're going to exchange our x and y to make our new equation. X equals negative 2/3 y to the 3rd power. So how do I get, if you want to, you could multiply by the reciprocal, like negative 3/2. If that doesn't make sense to you and you just want to get rid of fractions and multiply everything by 3 first, that also works. So I'm just going to go and do it that way. So we're going to multiply everything by 3. So I end up with 3x equals, here the 3's cancel, and I get negative 2y to the 3rd. And again, we're trying to get y by itself, so I need to get rid of that negative 2, so I divide by negative 2 to both sides. That cancels. We get 3x over negative 2 equals y to the third power. And then what do we do to get rid of that third power? We take the cubed root. So we take the cubed root of y cubed, whatever we do to one side, we do to the other. And for these problems again, we're going to go ahead and just leave them like this. So I end up with y to the negative 1, or we really should write it as f to the negative 1 of x, equals the cubed root of 3x over negative 2. And that's your answer. Okay, graphing functions and their inverses. Remember that an inverse, this should be inverse, no D there, interchanges the x and y values. Therefore, it interchanges the x and y coordinates of the graph. So the graphs of an original function and its inverse are symmetric about the line y equals x. And on a graph, y equals x, if you have your coordinate plane there, y equals x is like the line that goes diagonal straight through the point of origin. So this line right here, that's y equals x. So that means they're symmetrical across this line. So oftentimes when you're dealing with graphing inverses, the easiest thing to do is to first graph your original function. Because if you go back and look at, here's my original function, and then here's my inverse function. Your inverse function is a lot more complex. So if you graph your original function and then just exchange x and y values, it's much easier to graph the inverse. Okay? And when we're graphing these, you would be able to graph this line very easily because this is the same thing as y equals 2x minus 1. And you guys know how to go and you plot negative 1 on here and then use your slope up 2 over 1. But because we want to use points, we're going to go ahead and plug in values and get points here to make our line so that we can then use the same points to graph our inverse. Okay, so this is my original function, my f of x function. I'm going to make a t-chart with my x and y values. It's always good to have positive values, negative values, and then also 0. So I'm going to go ahead and use 2, 0, and negative 2 for x. So when I plug 2 in here, I get 2 times 2 minus 1, and 2 times 2 is 4. 4 minus 1 equals 3. We plug in 0 here. 2 times 0 minus 1. 2 times 0 is 0, and 0 minus 1 is negative 1. This was 4. Okay, plug in negative 2. 2 times negative 2 minus 1, we end up getting negative 4 minus 1, which makes negative 5. So if we plot these points for our f of x, my first ordered pair is 2, 3. So I go over 2 on the x and up 1, 2, 3 on the y. My next ordered pair is 0, negative 1. So 0 on the x and down 1 on the y. And my last one is negative 2, negative 5. So I go left 2 and down 1, 2, 3, 4, 5. And I draw my line. And it's best to label them, so I'm going to label this one as my f of x. Okay, and now I'm going to do my inverse function. So my inverse function is f to the negative 1 of x. And I'm going to make my t-chart x and y. And I don't actually have to do any work for the inverse. All I'm doing is exchanging my x and y values. So instead of writing 2 for x, I'm writing 3. And then my y value is 2. So I'm just flip-flopping my x and y values. So same thing on this one. I'm going to have negative 1, 0. And then my next point is going to be negative 5, negative 2. So now you're going to plot these on the same graph. So on the x-axis, I'm going to go right 3 and up 2. Then we have -1, 0. And then we have -5, 1, 2, 3, 4, 5, -2. And then we can draw our line. And that is my inverse function, which is f to the -1 of x. And these lines are symmetrical across the line y equals x that goes through there. If I drew it a little better, you could see that better. So the last thing they ask us is your inverse function, is your inverse a function? So my inverse is the purple line. So remember, we can use our vertical line test where this purple line can only hit one point at a time on the x-axis. And if you look through there, that purple line is an inverse. So we say, or is a function. Yes, the inverse is a function. And that's your answer. Okay, and again, what I meant by is the inverse of function is, does this purple line pass the vertical line test? Does it only hit one point at a time if you were doing your vertical line test? And it does. Okay, let's go ahead and move on. All right, so we're going to do the same thing here on example 7. The one thing you want to pay attention to on example 7 is that you have the 1/3 there in front. So you want to pick powers of 3 for your x squared so that it divides out and makes good points. So we're going to do our original function, our f of x function. We are going to plug in x and y values. And so the values for this one, I want to use 3's. So I'm going to use 3, 0, and -3 so that my fraction will cancel out any fractions that I have. Okay, so when I plug in 3 squared here, 3 squared is, in fact, I'm going to write it right here for a minute. We have 1/3, and we're going to go 3 squared minus 2. So 3 squared is actually 9. So that means you have 1/3 times 9, or 9/1 minus 2. And then there, that means that 3 goes into 9 3 times, and then you have 3 minus 2, which makes 1. Okay? When I plug 0 in here, 1/3 times 0 squared, well, 0 squared is 0, 1/3 times 0 is 0, and then 0 minus 2 will give me a -2. And then when we plug in -3, okay, so let's just write that one up here too. So we're going to have 1/3 times -3 squared minus 2. Well, -3 squared is a positive 9. So I end up with the same thing here. 1/3 times 9 minus 2, well, here the 3 cancels the 9, makes it 3. 1 times 3 is 3, and 3 minus 2 is 1. So this is 1. Okay, so when we graph this function for the x, we go right 3, 1, 2, 3, up 1. Then we have 0 down 2, and then -1, 2, 3, up 1. And this is making a parabola, which makes sense. When you have an x squared term, it makes a parabola. So we're going to draw that there. And that is my f of x original function. Okay, so now our inverse function, our f to the -1 of x, all we do is exchange our x and y's. So when we do that, that means I'm going to have 1 and 3, -2 and 0, and 1 and -3. So if we go and plot that, we go right 1, up 1, 2, 3. Then we go -2, 0, so -2, 0, and then 1, -3. So if you notice here, this ends up making a sideways parabola. And that's my f to the -1 of x. If you were to do the vertical line test on this one, notice that it would end up hitting 2 points. See that? So therefore, the inverse is not a function. So we are going to write no, the inverse is not a function. Okay. Example 8. It says, find the inverse if it exists. Okay. So basically we're kind of stating the same thing, if it's an inverse or not. So on h of x, it gives you the 2 points. So my original function, h of x, we're just going to go ahead and plot those 2 points. It is negative, actually, we just want to find if the inverse exists. So let's just do the inverse on this one. So we have our original function there. My inverse, so h to the negative 1 of x, is we're just going to interchange the x and y's. So my first point will be 5 comma negative 3, because I'm exchanging those x and y's. And my next point is going to be 5 comma negative 2. So if we plot our inverse function, it goes right 5, 1, 2, 3, 4, 5, down 3, 1, 2, 3. And the other one is 5 over 5 down 2. Well, is that a function? No, because if you did your vertical line, it's hitting 2 points. So no, the inverse is not a function. Okay. Example 9. So let's do it the same way as we did before, except for we're not going to have to graph our original function. We're just going to graph our inverse. But in order to do what we've been doing, we need to get at least 3 points here. So for our original function, f of x, if we plug in, let's go ahead and just use 2, 0, and negative 2. You can use any 3 values that you want to, as long as you have a positive, a negative, and a 0. You could have used 1 if you want to. So I plug this in. 2 squared is 4, and 4 plus 3 is 7. Plug in 0, 0 squared is 0, 0 plus 3 is 3. And negative 2 squared gives you a positive 4, and 4 plus 3 is 7. So there is my original function. And then my inverse function, f to the negative 1 of x. We are just exchanging our x and y values. So we are flipping these around, and we end up with 7 and 2, 3, 0, and 7 and negative 2. And I don't know if you noticed, like for instance on this one, you saw that the x is repeated. So you know it's not a function even before you graph it. On this one, do you think this is going to be a function? And the answer again is no, because the x's repeat. And if we graph it, we're going to go over 7, 1, 2, 3, 4, 5, 6, 7, up 2, over 3, up 0, and then over 7 and down 2. And again, we get a sideways parabola. So I don't know if you guys notice anything, but again, no, the inverse is not a function. Let's write that down. But if you look back at our examples, basically anytime you have x squared or a parabola, the inverse of the parabola is not going to end up being a function because it will not pass the vertical line test. Okay, so on example 10, all they've done is given you 3 points. So your original function, we can call that f of x. Let's go ahead and write down each of the ordered pairs. So the first order pair is at negative 1, positive 1. The second one is at positive 1, positive 2. And the third one is at positive 1, 2, 3, comma 0. So that's my original function. If we do our inverse function, f to the negative 1 of x, we are exchanging our x and y values. So that means I'm going to write this one as 1 comma negative 1. 2 comma 1, and 0 comma 3. And without even graphing this one, do any of the x's repeat? No. So for this one, the answer is yes, the inverse is a function. And that is it.